Hello everyone, let's go on a virtual lab tour. But first, a pre-recorded introduction.
My name is Ben Appleby and I'm in the Samaniuk Research Group. Let's go on a lab tour.
Ba-da-da! To the lab. So as you can see, our lab is very busy, so you know that we've been extremely productive. And then in the corner, we have a nice new looking water purification system that was a pain in the butt to set up, but it looks nice. So, this is the first exhibit of the lab, and basically a major theme in Joe's lab is he really enjoys novel experimental setups because one, it's a great skill to learn building something new and also just getting your hands dirty and building something up. And also, it's a good way to introduce novel concepts or push the boundary of what's currently done with state-of-the-art. So this setup is run by Shalaka Kale, and she is one of the founding grad students in the lab. And basically, this setup is a microreactor setup. So we have those copper-colored magnetic coils. It moves around a colloidal particle to measure viscous and elastic properties. What's great about this setup is you can induce noise with those magnetic coils to then measure stronger viscous and elastic properties that aren't really capable with state-of-the-art devices. Then from there, Shalaka has also been working on a radial trough setup. So this radial trough setup is cool because you can characterize an interface and you can visualize it. Basically, in this circular region, you can set up an air-water, oil-water interface, and then those fingers can expand or contract that interface, and then you can measure the surface tension of the interface, characterizing what's going on there. But on top of that, it's small enough you can put it on top of the microscope to also visualize it. So both characterize and visualize. From there, we have a whiteboard. It is also very busy, so you know we're productive. And the guy in green is David Goggin. He is one of the other founding grad students in the lab. And we're going to look at one of his projects in a second. So, this is our lab space. Undergrads have been busy as well. And this is one of the best rheometers in the lab. It's a DHR3, and simply it has this upper setup that you can attach various geometries to. For example, a cone, maybe a vein. It'll attach here, and then as you spin it in different kinds of materials, you can measure viscous and elastic properties of those materials. What David is working on is using this rheometer, but with a subphase exchange cell. What's going on here is we have this annular region, and we can fill it with water, and then put cyclopentane on top. And with these two mixtures, we can make gas hydrates. And how we do that is we lower the temperature, we form ice, and that ice adheres to that nice cyclopentane water interface. And then from there, if you continue cycling temperatures from high to low, then you can get cyclopentane forced into those hydrates. And then, all the while, you can have a ring sort of sitting nicely in this annular region that is then connected to the rheometer. So then as you're measuring those mechanical properties, you can track changes in mechanical properties indicating growing and then degradation of hydrate formation. So how we do hydrate degradation is with these ports. Basically what's going on at the ports is you can evacuate water from one port and then from there add an anti-agglomerant, and that essentially breaks up any sort of hydrates. So this is a setup where we can look at hydrate formation and then hydrate breakup. From there we have a Langmuir Trough. And this Langmuir Trough is a traditional way to characterize interface. And this tan band here does that expansion or contraction of an interface, and then you can also measure surface tension. Or you can also just take this bottom assembly part, stick it onto the rheometer, as we just saw a second ago, and use that same ring setup to measure the viscous and elastic properties of that interface. And then also, excitingly in the corner are some white 5-gallon buckets that are filled with drilling mud. So that's one thing I've been working on to characterize drilling muds to better understand how they could be used for tunneling applications. Because essentially what they do for drilling muds is they pump them down the tunnel, and then from there, as the drill head is drilling into some kind of soil, that drilling mud removes it from the drill head, and some of it leaks into the soil formation, some of it comes back out. But overall, if you can understand the flow properties, then you could optimize it for tunneling, making it more efficient. From there, we have a fume hood. Ooh. And then we have another rheometer, is the Aries G2 rheometer. So this rheometer is special because we have a setup in black there that can be used for high temperature rheological measurements, such as for polymer solutions or the sorts. Lately, I've been using it for clay samples to measure the mechanical properties of clay to see how we can modify it for tunneling applications. And then beyond that, we also have an oven. And overall, that concludes our lab tour. And a quick plug about our group and our advisor is just generally, we are very supportive of one another and happy to talk to each other. And I think we all really enjoy what we're doing. And at the same time, we like to learn more about what everyone else is doing in the lab. So in general, the culture is very supportive. And at the same time, our advisor is really great. Joe's a nice guy in general. I've honestly never seen him angry or annoyed or upset. And he's very supportive in whatever you're doing and really encourages self-driven research. So, but either way, if you need a lot of help or a little bit of help, he'll be there to help you along the way. So with that concludes our lab tour of the Samaniuk Research Lab, and I hope to see you all this fall. Bye-bye.